it for about 4 years. So I'll tell you a little bit about the story of how Facebook as a company transitioned from having a small mobile team to a company that focuses on mobile as a first priority. So let me start with a story here. Back around 2010, 2011, Facebook had a very, very small mobile team. For some context, if you guys don't know about this, Facebook started in 2004. It started as a web application. And then with the transition, with the large number of devices appearing in the market and mobile being a very important thing, Facebook started a mobile team. Around 2010, 2011, which is when I joined Facebook, we still had a mobile team. And we realized, well, it doesn't really make much sense on how to scale our app if we have a mobile team and the rest of the companies focusing on our desktop application. We had product developers, product managers, and product designers, each for each feature in our website, focusing only on www. And we had a team that had probably like a dozen of developers focusing on everything on mobile. Well, so what did we do? We realized that this was not going to scale, and we started building a bunch of these experiences on mobile. And as we finished building them, we transitioned the ownership to each of the product teams. We continued doing so, and as of today, we no longer have mobile teams. So if you guys come and ask us, oh, hey, what is the size of your mobile team at Facebook? We just say the whole company is focusing on mobile. And I really want to emphasize this. So what happens here? When we transition our company into focusing fully on mobile, we're injecting hundreds of developers into each of our mobile code bases. There are a lot of interesting challenges that arise from this. So I'll tell you a couple stories around this. So that's on the context of our engineering size and culture. But let's look at it from the other point of view, our users. As of today, we have 1.3 billion mobile monthly actives. And they are using our app all over the world, under different network conditions. You guys know about the Android fragmentation problem. It's a benefit, but also it's an interesting challenge. That means that there are lots of people in the world that are able to have internet-connected devices now. And because of this, we're building the application. We're in a really, really good position where we're building the application that allows them to connect with the world and their friends and family. So this is a graph of the projection of internet-connected devices in the next couple of years. It's made by this third-party company called ADC, and here I'm separating in the yellow section the developed markets, and the blue ones the emerging markets. Now, that sharp ramp-up, that sharp graph indicates that in the next couple of years, we will have a ton of users coming injected into the Android ecosystem. And they're not going to have phones like the ones we have in our pockets. They're going to have phones that will probably have the hardware set that back in probably like 3 years ago were the newest phones that we had. So we have a lot of interesting engineering challenges to handle here. And because of this, we need as many developers in Facebook to be tackling this, not just the mobile team, obviously. So today, I'm going to tell you about broadly mobile at Facebook. And I could keep talking over and over for hours about this. I've picked a couple selected topics here. First, I guess the context is we have 1.3 billion mobile monthly actives, and this number is growing every single day. What do we do about this? How do we handle it? What are the interesting problems that arise? We also want to make sure that we ship really, really fast. Just because we have a ton of devices and a ton of users does not mean that we should be slowing ourselves down. We ship an APK every week now. Many of you guys, as you guys are Android developers here, you realize it's actually really, really tough to do this. In addition to that, we have a ton of features in one single app. We have a ton of developers. We have our app is feature-packed. How do we do it so that we do this in a very reliable manner. On Android, native clients in particular, we have a very low tolerance for error. We're dealing with state, memory, networking, a lot of these things that are very, very tricky to deal with in a very, very constrained environment. And once we actually ship something out, we can't assume that with the next release, no one will be seeing these versions. We have a very low tolerance for error. So I'm going to tell you a couple stories about how Facebook handled a bunch of these problems while scaling in size and speed. So 2 ways. First, I'm going to talk about coding at scale. And the second part is how we release to the world in a very fast and speedy and reliable manner. So let's talk about coding at scale. So I guess like story time. Around 2011, when I started at Facebook, this was also coincidentally the time when we were transitioning from having just some small core mobile teams and having the whole company jump in and do Android and iOS development. Okay, so was it as easy as it sounds? Obviously not. It was actually really scary. I remember almost like, in my mind, almost overnight, the code base had transitioned from probably a dozen engineers to hundreds, like probably 100 engineers. I'm probably overreacting. It was probably like 70, but it's still a lot. So how did this affect my life? You could never build. Everything was crashy. When you thought your feature, when you finished writing your code, nothing worked. So obviously we realized developer efficiency was going to be affected by having a lot of people writing a lot of code. So we realized that we had to make some infrastructure changes and cultural changes for this to work out. You can't just transition from having 12 engineers to 100 in one day and not expect hiccups here. So we realized, well, first we need to create an environment that enforces testing and also makes it easy to write more tests, just to avoid brutal code. And the second part is we need to break dependencies amongst the different teams. What does that mean? If I'm working on newsfeed and something on the photo upload flow breaks, or is using a lot of memory, me as a newsfeed engineer, I should not be blocked by that. And I should be able to build my code, and you should be able to deploy it. Okay? So what did we do? So we started using dependency injection. So many of you guys are probably familiar with this, but for those who are not, dependency injection is a design pattern for externally setting object dependencies and separating the creation versus the behavior. What this does, naturally, is that it encourages modularity and testability. Now, you guys are probably familiar with dependency injection frameworks like Dagger, for instance, and Juice. Back in 2011, Dagger was not available as an open source framework, and Juice was giving us performance problems. So we developed our own internal one. But the inspiration and the same principles are still applied. Now, let me give an example for those who are not familiar with this. The idea is, let's say I'm creating a method that fetches data for my newsfeed. Let's call it newsfeed fetcher. And it requires a lot of different objects. Say something, an HTTP request helper, so that you can fetch something. Some sort of JSON parser, and some sort of image downloader. All of these are modular classes that perform separate objectives. So one way to construct these dependencies in a naive manner is just within your constructor or within your main method, within your class, initialize them, call new HTTP request helper, new parser, downloader, etc. Okay, so what happens here? So the problem in that case is that you have to be you tangle a lot of the dependency creation together with the objects, and it's really, really hard to test it. So with dependency injection, the idea is that rather than creating your dependencies, you're going to assume that they get passed to you by some injector class, or just get passed to you by the constructor. And you get this add inject annotation. What this add inject annotation does is it goes through all of the methods that were annotated like this and creates an injector global object, a singleton, that when we're asking for a particular object fetch newsfeed method, will pass all of these objects during instantiation time. And it will also, if you want just one instance of it, it will hold that instance and we won't recreate it. What is the nice thing about this? If you're writing tests, you can pass fake versions of it. You keep a very clean interface. And the other part is that you can build your own module and then connect it to the other ones as part of the final version when deploying and compiling the app. So this encourages testability, code modularity, and also helps us scale our code base. And this is obviously really, really important when you have tons of developers writing code at the same time. So one of the problems here is performance. Let me illustrate why performance is a problem. It lies on the area of dependency resolution. So at runtime, because you don't really know who are the objects that you're going to be depending on, we realize, OK, you hook the newsfeed fetcher to this HTTP request helper, this parser, and this downloader. It's not until you initialize the app during cold start that you're doing all of this stuff. Okay. This takes us to a different problem. In order to have all this flexibility, our cold start time is just going through the roof. So what do we do here? So we can actually switch all of this to compile time. But if we hard-coded everything, we would go back into the old method where everything felt wired and like static, and we wouldn't be able to write tests in an easy manner. So one of the engineers at Facebook thought, OK, instead we should look at the Java bytecode and modify it at compile time to substitute the creators of these providers into static methods and actually wire them to the final versions. And when you're doing tests, you still get the flexibility. And at the end of the day, we reduce startup time by 20%. And you do all these operations at compile time, which happen offline. OK, so that's just one example of how we actually broke down a lot of our development process, what type of infrastructure that we actually put in place so that we could move really fast in an independent manner. Here's another example of a diff that we send out for review. A lot of the internal details are blurred here for confidentiality purposes. But what I want you to pay attention to is kind of like the green and red blocks here. Every time we send out a diff for review, we run a lot of tests, both unit, end-to-end, and screenshot tests. This helps us prevent brittle code. And if we create the right framework for the different teams to start being able to write code, we will be able to identify a bunch of these failures before we even land the code so that our trunk is in a healthier manner. OK? So the other part, another trick that we found out that was very, very useful when scaling a mobile organization is identifying common APIs. Let me tell you one example of a case study. So if you're working on a feature at Facebook, there's chances that you'll be needing to download some data from the cloud, cache it somehow locally, and show it in some sort of UI. Okay. So this obviously involves writing some sort of code. And well, the reality is that we have a lot of features and a lot of engineers, and each of them writes their own version. Now, why can't this be abstract? Well, you might be wondering, why can't this be abstracted into a common library? Well, let's think about the case of, say, fetching your newsfeed versus fetching photos, fetching events, et cetera. The structure of your query changes drastically, depending on what you're trying to do. So there is some sort of custom code that has to be written. So you can't just you can call a general HTTP library, but you still have to construct the parameters that you're asking, like the API call with the parameters that you want. OK, so this happened across the board. And at some point, one of our engineers decided, hey, this underlying API method call, I'd like to optimize it. But then he realized, in order to make an optimization to the fetching mechanism, you have to change every single line of code in many, many different products. And when you do that, it doesn't come for free. It's not that simple. You could be breaking some other product code. And people get pissed, and it's actually really, really tedious. So one of the ideas that we came up with is instead, write a small snippet of what you're trying to, in a small snippet of a text file, specify what you're going to try to download from the server. And have a library auto-generate the actual API method calls from that templated version. What this does is this allows for making changes in the particular underlying architecture to be much easier and not affect that much of the product internals. So the engineers that work on this type of optimizations and developer APIs at Facebook are called product infrastructure engineers. And their objective is to make it easier for product teams to develop faster. So I guess that's kind of like my high-level overview of how Facebook as an organization has scaled from having a small group of engineers working on mobile to the whole company touching it. Now I'm going to switch gears and talk a little bit about how we release our app into the world. So if you guys were at the talk yesterday on emerging markets for Facebook, we talked about how we have over 10,000 different Android devices out there. Over 10,000 different devices are running Facebook, which is kind of scary. We need to make sure that our app works in all of these cases and is not creating a terrible experience. So how do we do that? Well, we have a ton of different layers of support here. The first one is employee dogfooding. Let's say I'm building up my particular feature, and I'm pretty sure that it works, but I don't know. There's 10,000 different devices. There's a lot of different connectivity types, and to be honest, a lot of different use cases. So we rely on our employee dogfooding program. We have thousands of engineers at Facebook, and we really encourage a lot of them to use Android. And we have this rich feature support. Again, if you provide the right tools for people to report a lot of this information, it makes it easier. So if you find something that doesn't feel right, or an experience that is really bothering you, you rate shade your phone, and then you get to write an employee report. So is that enough? Well, the answer is no. So we take advantage of the Google Play's alpha and beta channels. We have over 100,000 alpha users, and we have a little over 1 million beta testers right now. So we release our app into alpha every day, a new version of master into that, and every couple days into beta. This allows us to turn on our features early. So if you guys are interested in staying up to date with the newest Facebook features, we turn them on much more often in the alpha and beta channels, and we turn them down in production. So check out these channels. By looking at this, we're able to identify crash rates mostly, and see some of our obvious built-in problems. Now, this is not perfect because most of the users in the alpha and beta channels have really high-end phones. Most of the phones are Nexus phones, so it's a little skewed towards a very tech-oriented audience. Nonetheless, that is very helpful. Well, so if everything passes here, everything looks good, we release to a small percentage of the world. Now, I mentioned this is a release, like we have multiple releases of different products all the time, but we're very, very careful. Sometimes if we're looking at product changes that affect a lot of users and are pretty obvious, we run tests in countries in particular to see what are the longer term network effects there. And sometimes if it's something smaller, we will run a 1% test, look at engagement metrics, and keep rolling to a larger audience that way. But is this enough? The answer is no. Let me tell you a story about something that we didn't catch in the employee dogfood program, the alpha or beta releases, or even like when we rolled it out slowly. So this was in the context of a photo uploader. So I guess this code might look familiar. If we are trying to show a progress bar for uploading photos, your code might look something like this. Obviously, I simplify it a lot here. Here it's saying, hey, you're uploading photos at 70% of the total. So we go through a phase of internationalization of strings. So obviously, when you want to put a number in Android, you will do a placeholder %d, and it will actually substitute a number. So that's probably pretty clear for this crowd. When we translate stuff, we send our strings, the uploading photos, whatever, into our internationalization console. And we have a lot of volunteer translators. So in the case of Finnish, Danish, and Polish, we had a single translator doing this. They thought, oh, this %sign was probably a mistake. So they removed it in the translation. OK, so what happens here? There's no crash. No crash happens here. Well, there's a crash, but there's no compilation mistake here. So everything still builds. Depending on how you write your code, it could be a soft error, or it could be a cancellation of uploads, or it could be a crash. So regardless, this means that our users in the Nordics are not getting photo uploads. Now, the reason why this was even more subtle is because we have separate experiences for low-end phones and high-end phones. So this was just happening for gingerbread users in Finnish, Polish, and Danish. So we did not have anyone in the alpha or beta channels that used any of these particular cases. So, OK, how did we catch it? We immediately saw a drop an increase in upload failures. In this particular scenario, we drilled more into this, and we identified this. So we have very, very targeted instrumentation tools so that we can identify large changes in engagement. And sometimes, many of these are related to releases, and then we can actually bisect and identify what the particular problem is. So I guess, is this enough? Well, so I touched a little bit into the analytics. How do we understand that our app is doing well once we released it to the world? So we have a lot of dependencies and a lot of tools that we can use. Examples are crash logs, bug reports, and Google Play Store reviews. Now, everything in this form comes like a snippet of text, even a crash report. If you look at your ADB stack, you're waiting for the particular pattern, you're catching it, and you're storing it. None of this is structured, right? Especially rate shake reports. People say, oh, my feed is not loading, or I can't comment. These are examples. So, but we get thousands a day reports of this kind, mostly because of our magnitude. So one of the things that we do is we use machine learning and natural language processing to cluster a lot of these reports using keywords, and we identify which are the main categories. This allows us to focus on the most pressing bugs and be able to cut by different device classes, features, etc. And this is how we identify some of our most alarming bugs, and we have task forces to focus on them in particular. Examples are like, hey, if people can't what's happening here? Or if your newsfeed is not loading, can we drill down and understand, add more logging, and come back and forth? So this is an example of a screenshot that our engineers look at when they get a crash. I have, again, blurred a bunch of our internal data here, but the structure here is that to the left, you get your stack trace after all the clustering that happened. And to the right, we get aggregated crash summaries. For instance, how often is this happening? What device classes is this happening? Since which version are we seeing a lot of this stuff? How can we, these are all the tools that we can give our engineers so they can reproduce this and address a lot of these crashes in a much more promptly manner. So ever since we started having these tools, this helped reduce crashes by 75%, which is a lot. What does this say? If we build the right infrastructure, we build the right tools, we will be able to target the problems in a much clearer manner. So that's all I have here today. Looks like we have a much larger slot, and I have a 30-minute talk prepared, but I'll start taking questions. Yeah. And there are a bunch of us from Facebook here if you guys have broad questions as well. Yeah.
How do you assess the severity of a bug, or how do you prioritize bug fixing across the different clusters?
OK. So the question, I'll repeat that, is how do you prioritize? How do you identify the severity of the bug, and how do you prioritize it? Well, so remember that slide that I talked about where we have a lot of input of reports, crashes, etc. So we have information like how often is this being reported. So if people are pressing the report a bug button, the more they report it, it indicates a lot more severity and like a broader use case. So we have a program at Facebook called the Countdown. The Countdown kind of like program where we look at all of the bugs that are being reported, the ones that are reported the most, and we have specific task forces to handle each of them. Some of them are easier than others. Some of them are because we release something by mistake and we can do immediate targeted fixes. Some of them are more subtle. Let me give you an example. We had a like reliability problem at some point. People couldn't like, but if this was really a mainstream, like obvious problem, we would have realized this and we could have targeted. It was not the case. It was pretty subtle, and we broke down a bunch of the different cases by adding a bunch of logging and looking at what are the reports are. In some cases, in low connectivity scenarios, people were hitting like, but this was not propagating, and they hit like a lot, like and like and like. And our site integrity or like our spam filter detection mechanisms realize, okay, you can't be liking this story a ton. We think we're gonna block you. We're gonna sentry block you. So, but this was happening because people were pressing this back and forth. It was queuing up on the client side, and when the connectivity came back up, all that queue of likes and unlikes requests was coming out to server. Okay, so we were able to identify that, and we were able to remove all those likes and unlikes and fix that. So that's one example of a problem. But since it's affecting some of our core functionality, having signals of how often it's being reported, like what are, like helps us identify the severity of them. Does that help answer your question? Yeah.
What sort of testing processes do you have in place in order to allow you to release it on a weekly basis?
Okay, so the question was, what type of testing processes do you have in place to that allow you to release in a weekly basis? Okay, so we just started switching our release, like transitioning from a 2-week release cycle to a 1-week release cycle recently. And so let me give you a little more historical context. We used to release once a month. We used to not have a release schedule. We were waiting, like we were ready to release, and then we released this. This is back in the days when we had probably a small mobile team. Okay, we had like a big rewrite, we released it. Then we switched to release once a month when we started having a lot of people developing in the code base. We used to have a month soak period and a month, like you branch cut and you have a month soak period, and only bug fixes go in there. It was really tough because suddenly, if you couldn't get your feature for the month, you had to actually wait for another month, and reliability was super important. So we started by having a lot of unit tests, like setting a lot of the dependency injection framework integration was mostly so that we could even write unit tests. So that started first, and then with time we realized that, hey, now that we're releasing every week, it's really hard to have manual testing in place. We used to have a QA testing team that looked at a bunch of the core interactions to make sure, say, you could load your news feed, you could post a photo, you could like a story, like a lot of our core interactions before they would manually test a lot of our core interactions before we shipped. Now, with a 1-week release cycle, that's impossible. So we are so we have a really good end-to-end testing framework on screenshot testing framework that we use now. A screenshot testing framework, it operates a lot like a unit test. It allows you to separate a lot of the components, and it takes a screenshot of a lot of the UI that you have so that it can compare it with the old version, and you can tell. And it can ask you, hey, do you mean for this to be a difference? So if we have undesired changes, we can actually identify them early. Our end-to-end tests are meant to substitute some of our manual testing, and we're as a principle, we're asking all of the product teams to start transitioning to this. So how do we enforce it? Is we have this concept of a test storm happening. At Facebook, we have a lot of kind of like trials of what would happen if our data center, if X data center went down. So we want to actually understand our weaknesses there. So what would happen if our QA testing team just was not available? So we're having a test storm planned where our objective is to transition a lot of our manual testing into end-to-end tests. So the answer is there's a mix of stuff. We have a lot of tools now that allow us to write all the way from unit tests to end-to-end tests. And the idea is to prevent regression so that we don't have to be fixing stuff after launch. Mm-hmm.
How do you find the balance between like the staged rollouts, just like 1% or whatever, versus having like a consistent experience across all customers?
Okay. So the question is, how do we find the balance between a staged rollout and a consistent experience amongst different people? Well, so we release our app once a week, and that is a staged rollout on its own. We want to make sure that we monitor a lot of things like crash rates, bug reports. So we want to be very, very careful about not introducing a release that is bad for our users. So in that sense, we'll have a gradual rollout. That being said, we do a lot of experimentation on our features because we want to make sure that whatever we roll out to 100% is the best experience for our users. Let me give you an example. When we redid the way we navigate to open comments, we had a new, very fancy design that when you tapped on comments, it opened a pop-over. It was bouncy. It was very friendly. But we found out that hey, if you actually looked at low-end device users, they were actually having a terrible experience. They were commenting less. So we dug in a little bit more. We actually opened this in low-end phone, and we realized that the animation is so choppy, there's really no point in having it. So if we had released the one version to everybody, we would have heard our low-end users and seen better engagement and have a better, more delightful experience for our high-end users. But because we had all the way to look at all this analytics, we were able to pinpoint that for some users this is bad, and so for some users it's better. So what we did in that case is we turned off animation for our low-end users, and they actually got to experience the full screen behavior that we had, which was better than the old one, but they didn't need animation that was going to be choppy anyway. So I guess to answer your question, one of the things we learned is that there's no one-size-fits-all for everybody. There's a lot of diversity in device models, in screen sizes, in usages, in general usage. Not just from your device, but also culturally speaking. For instance, people in different countries have different ratios of friends versus page content, and people use Facebook in a slightly different manner. So the important thing for us is to be able to understand their users in the best manner and provide them what will make them have a better experience. Yeah?
Do you guys leverage any feature flipping?
What do you mean?
Like ship a feature turned off and then turn it on later?
The question is if we leverage any scenarios where we turn on a feature, then turn it off and turn it on. I can't think of a particular one, but do you have an example in mind? Mm-hmm.
Right? You ship one build with a flag that says use this like button or that like button, and then you turn that on and off to determine which one's better. I mean, you can use for A/B testing, or it could be good for, I guess, keeping code that's not yet ready for a full release, but not holding up your release.
Yeah. We do that all the time. In fact, we have a lot of experiments running simultaneously. We have a very good experimentation framework. It was built internally. Literally, probably every single product change and any large infrastructure change will go through experimentation here. The context being, for instance, if you have a refactor, you want to make sure that all your metrics are neutral And if they're not, you won't understand why, because it's probably a bug otherwise. For our products, we constantly roll out like this in terms of tests. The setup of the test matters. Like it varies a lot depending on what the test is in particular. But is there something in particular you had in mind?
No, I'm just curious if you do that and then you do that like at build time with variants, or so you get a particular APK that's configured a particular way, or is that controlled
Server control.
from your server?
It's all server controlled. So the way it works is that we have the system we call it is a quick experimentation system. It's like internally we call it like that, and also we have a gating system for that. And a lot of the signals every 6 hours we download some small snippet information, which is like imagine a table. It's like a name of experiments mapped to the group that you're assigned to, and depending on which group you're assigned to, your code actually decides to turn this on or off, and kind of like log a lot of your engagement information, like your behavior, like the behavior of the user, depending on the flow. Mm-hmm. Yeah.
What kind of tools and processes do you have around code reviews?
Okay. The question is what type of tools and processes we have around code reviews. I guess, so it really depends by the team. So we are a very bottoms-up company in the sense that we try not to build things that are not necessary. But that being said, the common things that come up is automatically running the tests is something that has been found very useful across all the teams. So by the time your review comes back, we are able to run a bunch of unit tests or end-to-end tests in that case. I guess like we have general like linters and a bunch of like agreed upon patterns that we like to enforce so that our code is consistent and coherent across everything. What else? Yeah, I think at a high level that's what I'm thinking of. We do like to kind of like in principle say, hey, if you are done building a feature, because end-to-end tests are heavy and expensive, we start. Once you are shipped, or let's say we shipped this and we kind of gelled it, like we agreed on this as being the feature that we want to actually release, and in this form, we go back and start looking at what are the core tests that we would like to build and from the point of view of a user. I'm gonna try to do that. Yeah, we'll start here.
When you went from 12 engineers to 60 engineers on the Android platform, how did your code base change? Did you start to break it up into different modules or subtopics you get?
So there were a lot of, the question is, what happened when you switch from 12 engineers to like hundreds of engineers? How did your code change? From my memory, the biggest thing that changed was we started using dependency injection because we weren't able, because everything was tangled together and stuff was breaking. And if you could build a particular module and just not have to depend on it, it's actually really helpful. The second one that we built was that we developed because we didn't find a tool that could handle a bunch of our scale was Buck, our build system. So the way Buck works is that it builds particular modules and it doesn't rebuild them if they haven't changed. So it's Buck is general build system. It's actually open source. It's not specific to Android. It's part of our iOS build system as well now. But the advantage of that was we used to have a single repository. We still have a single repository, but each of our modules have to be like when building the whole thing, it would take forever. With time, what we developed was different ways of distributing the builds across different machines so that not everything lies on your laptop and your laptop doesn't look like it's I don't know, like starting up a rocket, like doesn't sound like a rocket ship. So Bug was pretty impactful. What other things do we change? I think we started, like the stuff I was mentioning here, how we fetch data from our servers. It's a framework called GraphQL. It's open source now. It allows us to effectively download, it's an API that allows us to effectively download data from our servers, but it's also it's tolerant to versioning. What do I mean with this? So we all know that our the versions, the APK that we probably released probably like a couple months ago, it's still out in the wild, and so we can't deprecate certain methods. So rather than saying, hey, this is the API, and we're switching it like this in the next release, which doesn't really work, well, we came up with an API construction that allows us to ask for specific parts. For instance, if we're rendering newsfeed, is pass me all the stories, pass me the message of it, pass me the link for it, pass me the photo. And what if in the next version of newsfeed we were not rendering photos, and we're just rendering everything like a text piece. And in the next version we want to have a rich media format, right? So how do we like repurpose this API so that the old versions still keep working and we don't have to change our signature a lot? And in the new ones, we can support a bunch of this stuff. We use the concept of a style list. The idea is in JSON, as part of your JSON, you have a style list that says, I want to render you as a photo. And as a photo, if it's as a photo format, you need to make sure that your image URL is there and a title is there. And if you can't render a photo, there's a fallback mechanism, which is just text, for instance. And this is how we grow. So that has been very helpful. So check it out. A lot of this is part of like a framework of GraphQL, but also a lot of this was custom within our team. Mm-hmm.
Do you design for the low end first and then progressively enhance, or do you design for the high end and then gracefully?
So the question is, do we design for the low end first and progressively enhance, or the other way? So we have someone from the emerging macros team here. Like, I don't want to put you on the spot. I can answer it, but it seems like you'll be able to add color. Okay, so I'll take a stab, and then Alex can probably add here more. To be honest, we tried to build empathy. That's the most important thing. One of the things we realized is that first, if you don't use an Android phone, if you need to use an Android phone every day so that you can understand how navigation works, what type of limitations of hardware we have. So we make sure that we really push everyone at the companies to start using Android. The other thing, a couple of things that we also tried is low-end phone versus high-end phone. Like we push about like this started by one of our PMs, Chris Maria, who started like raising a lot of awareness about the different types of phones out there. So he asked, can everyone carry a low-end phone and a high-end phone? The other part is we build a lot of APIs so that people can understand the data and be able to cut it across different device models and different connectivity models. What does that mean? Well, so if you guys attended the talk yesterday, we talked about how we have 10,000 different devices. And when we have 10,000 different devices, are you supposed to carry 10,000 different phones, test all of them? It's literally impossible to do that. So, but what we do know is that there are certain characteristics that differentiate them. The number of cores, like the screen size, basically their speed. So rather than thinking about each of the devices, we think about if you took this phone, the specifications of this phone, how will you map it to when was it the newest flagship phone in the US? So we think about the same way you think about car models. It's like, I don't really know about the models everywhere in the world, but I can think of, okay, this is a car that would have released in 2010, for instance. So we created this year-class model so that instead of thinking about 10,000 different phones, you think about probably 5 or 6, or really just fast and slow. So probably the ones in your pockets are the fast ones, and think about something that was flagship in 2011. So when we have this type of framework, we can cut our data across the board there. So that's one part, be able to understand your data. And the second part is also try to use this phone in this model. The emerging markets team started what we call like 2G Tuesdays. The idea is on Tuesday you will have an ad on top of your Facebook that says, a megaphone we call it, that says, can you start using Facebook as if we slow down everything and you were in a 2G network? Examples like this. So all of this is the objective of building empathy. So that our designers, our product developers, and our product managers can think about where are the problems that are happening over the world. In addition to that, we also have a lot of research field trips going to different emerging markets. So I know we go to India, Southeast Asia, we go to Mexico, and we interview a bunch of people and ask them about their usage patterns. This helps us to understand emerging markets as well as cultural differences too. Yeah. Do you want to add something, Alex?
Great.
Okay.
So you mentioned that you're moving to like a weekly release cycle. Just curious how you manage the exponential upgrade path so that users could potentially go through. Not to mention preloads as well.
Exponential upgrade paths? What do you mean?
So if someone didn't take your upgrade this week, they're potentially 3 weeks older versus 2 weeks older, and then next week there's an entire new
Oh yeah.
experience to deal with.
Oh, okay. So let me try. I'll try to repeat it for everybody. So when you switch to a 1 week release cycle and people haven't upgraded in 2 weeks, and this person hasn't upgraded in 1 week, suddenly you have the newest version that you had out, but really have a bunch of people in the prior one, the one before, and you just like it blows up a lot more than if you were like releasing twice a week, like twice a month, for instance. Is that the context? Yeah, the problem is that it's not simple. We've been dealing with this problem ever since we were even releasing once a month. Android in particular. iOS users actually upgrade much faster than Android users. It's probably pretty obvious why, because of the different network connections, et cetera, as well. So on Android, I guess to contrast a little bit with iOS, iOS doesn't have an alpha beta channel. We have one, which is nice. It's not enough fully, but we'll take what we can get. We still have versions that exist out there. I remember seeing like a bug of a version, like a server-side change that we made by mistake from that was breaking releases that a release that came out a year ago. So we are still handling we're still handling binaries that were released a year ago. And the answer for that is we have to be very, very flexible, and we really need to, we can never assume that that an APK that is released will disappear. So what do? We need to make sure that before we release everything, we have tested everything. This is why testing is really important. Instrumentation is super important, and we need to design the most important thing is that we need to design our server APIs in a flexible manner, because you cannot assume that you can deprecate a function. So rather than saying this is the version 1, version 2 of the APK of the API call, we need to invert it. We need to think about we need to think about how do you expose things where the client is saying give me this information, rather than giving, for instance, in the case of newsfeed, is give me the last 10 stories with this particular fields, as opposed to saying, just give me feed, because that will change, right? So if you tell the server, give me the last 10 stories with the message, with the image, with the image URL, is very different from just give me feed and I change the signature. So that's like by design in APIs that we have to do. So the question is if our infrastructure, I guess I'll rephrase it a little bit. It's like, let me know if it's accurate. Is which internal tools are open source that are available? So not everything, to be honest. So what we do is we want to make sure that a lot of the stuff that we open source is packaged correctly and it works well and is generic enough for people to use. We do open source a lot of stuff. The screenshot test work, the author is Arnold Noronha. He is an engineer in New York on the infrastructure team. He just released that. So if you are making a lot of UI changes and you want to make sure that stuff is consistent, check that out. It's called the Android Screenshot Test framework. Unit tests, we just use standard JUnit stuff. The end-to-end test framework, we're actually taking we're pulling from the open source framework community. We use Android. So we kind of repurpose it to use our internal tooling, but it comes from open source. The dependency injection framework is not open source. It's very similar to Dagger, so I encourage you to check that one out. Yeah. But check out our, so we have a page for a bunch of our, like our Facebook open source tools page that will have information about the different projects. Another cool one is Rebound. It's a UI library that allows you to make bouncy animations so that you can use Spring Physics to create like elements. Chat heads, that comes from Rebound. So I know a lot of companies have used that one. Yes? So let me see if I heard the question correctly. When you said that we transition from mobile to like a mobile, like to everyone like writing code, did they all have mobile experience? How do we handle a bunch of that? The answer is we need a lot of mobile engineers. Okay, we are hiring a lot for Android and iOS engineers. So if anyone is looking for a job, come talk to us as well. That's my plug for hiring. But the point is, at some point, because Android and iOS, like mobile technologies, are fairly new compared to say web technologies or systems in general. We could not hire enough people to work on Android. We could not hire enough people to like satisfy the rate at which we needed people. So a couple of things we did. The first thing is we hired an in-house company to come teach us how to do Android, Bickner Ranch. So I was part of the first class doing there. I was not an Android developer before I joined Facebook. I was actually doing machine learning and computer vision. So we transitioned there. One of the things we found out is that, well, you know, it's a language, it's a different framework, but it's still programming. You're dealing with building a system that is going to be having a lot of uptime in a very resource-constrained environment. So a lot of the people that have worked on systems and web can apply a lot of those that knowledge into Android itself, and they have to learn about a bunch of like kind of like the general like framework details. So we have found that a lot of our web and systems engineers at Facebook have been very have contributed a lot to how our internals and how our architecture patterns have been designed. The second part is we realized, okay, since we can't hire enough Android people, how about we train them? So at Facebook, we have our bootcamp program, which is, when we hire you into Facebook, we don't pre-allocate you into a team. We have some custom pipelines that do, but most people are generalists. And they go through 6 weeks of classes where they learn how to use our full systems. And back in the day, it was only the web and the C++ layer. And then we realized, okay, we need to add something for mobile, Android and iOS. So if you join Facebook now, after 3 weeks of learning how to use the general like web stack and the system stack, we give you the option to join the iOS track or the Android track or stay in the systems track. And at that point, we teach classes. The classes are all internal now. We develop our internal curriculum. For 1 week, you learn how to write Android from scratch without the Facebook libraries. You build an Instagram app, like a baby Instagram app. And after that first week, so it's a very, very intense week. And after that week, you learn a lot about how to use the Android-specific tools or iOS-specific tools. And you start talking to different teams. And then by 2 weeks in, you're already contributing to our mobile code bases. So this is how we have handled the fact that there's not enough Android developers out there. So we train them. And that has worked out well. And we're still looking for people, so yeah. Any other questions? OK. I guess if there are no other questions, I'll stick around here. Feel free to stop by, chat. Thank you.